Hi, everyone. I'm Bob Bowman, Editor-in-Chief of SupplyChainBrain, and I want to welcome you to this webinar presentation on automation innovation. From AI and analytics to machine learning and robotics, supply chains will never be the same. Now, this is the second of a series of two special presentations this summer from Gartner and SupplyChainBrain on surviving in the age of permanent supply chain disruption. I want to take a moment to thank our sponsors of this presentation. Six River Systems, Vector Robotics, Fortna, and Earhart Partner Group. And one little bit of housekeeping information as well. There will be a question and answer session at the end of this presentation, and audience members are encouraged to submit their questions at any time during the presentation by clicking on that Q&A icon at the bottom of your screen, and we'll get to as many of your questions as we can, time permitting. With that, I want to introduce our two fantastic speakers for today. First, we're going to be hearing from Bart de Monk. He leads Gartner's transportation technology research. He's a 30-year supply chain veteran with 25 years of experience in logistics. He's seen logistics change from a completely manual function to today's environment, where we continue to see accelerated adoption of digital models and technologies in transportation. We'll also be hearing from Dwight Klappich, who leads Gartner's warehousing and fulfillment technology research, which includes operations robotics. He's been researching logistics technologies for 21 years at Gartner and has over 40 total years of experience across supply chain technologies. For 15 years, he has led one of the most comprehensive studies of supply chain technologies from a business user perspective, and most recently has led Gartner's exploration of the exciting and fast-paced world of operational robotics. So with that, I want to hand it over to Bart de Monk. Bart, take it away.
Thank you, Bob, and welcome everyone to this webinar where Dwight and I will be discussing some of the technology innovations that are driving automation in the supply chains. Many businesses are managing constant disruption, and this is causing advances in digitalization as our supply chain leaders are looking to accelerate digital transformation. Current events such as the pandemic, economic pressures, shifting consumer demand, environmental situation, and social and political protests have required our businesses to continuously reset. Supply chain leaders responded to the challenges of the disruption. Often, these challenges require leaders to create new ways of supply chain execution to align to today's volatility, uncertainty, complexity, and ambiguity, or in short, this VUCA world. Following the many disruptions we're experiencing in this VUCA world, supply chain transformation is already underway, shifting the competitive environment. Nearly all executives expect working from home or working from anywhere will increase. Over 90% of supply chain executives are eager to support their CEOs as they are creating new business models that are key to support much needed growth. Chief supply chain officers must revisit and align their operating models to support company strategy and these new business models. And last but not least, the very foundation of businesses and supply chains, which is globalization, is under pressure. Pretty much everything in supply chain is changing. The way we work, the value we deliver to our clients, and the way we source, make, and deliver products globally. Digitalization and investment in technology remains one of the top business priorities for CEOs and supply chain executives in 2021 and 2022. Besides the workforce, technology increased the most compared to last year. And this increase is mainly due to the acceleration in digital adoption due to the pandemic. Artificial intelligence and machine learning continue to innovate multiple aspects of the supply chain. Advanced analytics is one of the top technologies adopted by supply chains to drive insights, to make business more agile and resilient while supporting their growth initiatives. Over the next 10 years and beyond, supply chains will become more autonomous. By then, hyper-automation, which is a combination of technologies that include robotic process automation, machine learning, artificial intelligence, and many others, will be pervasive in all aspects of the supply chain. This includes how demand is generated and how the supply chain is planned and executed. In parts of the supply chain, robotics will be used to drive efficiency and capacity. Expected benefits aren't just from employee reduction, but rather from unleashing trapped talent by freeing up their time from non-value-added tasks. Redefining supply chain strategy, driving innovation, taking care of customer service and experience, and controlling AI decision-making remain some of the human tasks in the autonomous supply chain of the future. Now, let's talk about some of these innovative technologies. Let's start with artificial intelligence, or AI. Many early adopters of AI had initially thought that full automation was the way to use it. Now, the unexpected COVID-19 pandemic helped them realize that full automation isn't necessarily desirable. They are taking a more realistic view where augmented intelligence compensates automation's limitation with people's creativity, flexibility, and adaptability. The supply chain AI use case prism identifies 21 AI use cases. Some of the top use cases that were identified are inline quality, which uses vision systems, deep learning, machine learning, and robotics to monitor parameters during inspection and in-process quality checks. And this reduces inspection time and unplanned events. Smart Factory, on the other hand, describes how the convergence of standard work with modern technologies creates a hyper-flexible and self-adapting manufacturing capability. It blends multiple analytics, AI, machine learning, and automation capabilities that improve factory reliability and delivery. And demand sensing, which uses data and predictive analytics to create a more accurate short-term granular demand forecast to support improved customer service and inventory location and allocation decisions. The artificial use case prism for transportation identifies a further 18 AI use cases, such as predictive ETA, asset performance, digital freight matching, and many more in and across transportation. The use cases span transportation planning, fleet management, transportation execution, real-time visibility, and customer experience. Some of those use cases, like predictive ETA, asset performance, and theft detection, exhibit both high feasibility and high business value, making them prime for adoption. Other use cases, such as autonomous trucks, while potentially transformational, are more complex. And accordingly, transportation organizations should account for the significant challenges across data availability, cultural readiness, talent, and technology. Similarly, companies must set realistic expectations for use cases like urban delivery robots, transportation forecasting, and digital transportation twins that demonstrate lower business value and lower feasibility. Advanced analytics. It's a big consumer of AI and machine learning capabilities. Analytics is used for many different purposes within the supply chain. And the top reasons are to improve process efficiency and reduce costs, followed by improvements in employee efficiency. In today's environment, organizations increasingly face major disruptions that significantly impact their supply chain operations. From tariff disputes to natural disasters and major supply failures, or more recently, the COVID-19 pandemic. With more available and reliable data, organizations are leveraging analytics to sense the disruption, comprehend its magnitude and impact on the supply chain, and then formulate a response. And to succeed, they must rely on a strong analytics competency that combines a broad range of analytics strategies and approaches. Where descriptive analytics could only tell us what happened in the past, diagnostic analytics could help us explain why. Now we have predictive and prescriptive analytics. We have the tools to create not just valuable insights, but to have also the intelligence to make decisions and even further drive actions. Supply chain executives can deploy a portfolio of analytics techniques while they sense current events, mitigate and respond to those events, and predict future disruptions while modeling and designing the future supply chains. Hyperautomation. It's the combination of multiple machine learning, packaged software, and automation tools to deliver work. The goal of hyperautomation is to automate as much as possible. That means in some cases, like in the warehouse, taking humans out of the loop. In other cases, it will augment the human to make him or her more efficient and handle more volume faster and improve quality. The path to automation is definitely not an easy one. Progressing from simple automation, where we might be dealing with things like identifying events to invoke task-based automation, to true hyper-automation through things like RPA or robotics process automation. We are still very much in the task automation phase today. Now we're moving towards process-based automation using workflow tools and intelligent business process management solutions to invoke conversational user experiences. The next step will be moving to automating across business operations. We call that at Gartner digital ops, and that is where we are using intelligence to help automate overall business processes. Autonomous trucks can be seen as an example of robotics in transportation, but autonomous trucks don't necessarily mean driverless trucks. In the US, many states have already paved the way for autonomous trucks to drive on highways, including Texas, Florida, and Arizona, considered hotbeds for autonomous pilots. Amazon has been using self-driving trucks developed by Embark to haul cargo on interstate highways. Too Simple is carrying payloads for UPS and the US Postal Service in Arizona, as well as New Mexico and Texas. And while the technology is still advancing, we have limited regulations to allow the use of these vehicles on a large scale. Autonomous vehicles can also play a big role in the last mile, where they are mainly being used for grocery delivery, meal delivery, as well as small parcel delivery. And finally, drones. They're another way to deliver small parcels to the consumer in the healthcare industry and retail.
Thank you very much, Bart. I want to take a moment here to thank a couple of our sponsors for this presentation. 6 River Systems is a leading fulfillment solutions provider, striving to make warehouses faster. A flexible, easy to deploy solution creates a work environment that makes it easier to attract, train, and retain associates, while powerful software delivers actionable insights that enable your business to lower the cost of fulfillment, better engage and retain customers, and quickly adapt or scale to meet changes in demand. Learn more about fast, flexible fulfillment at www.6river.com. We're also supported by Earhart Partner Group, EPG. The explosion of smaller orders and customer quick delivery expectations are rapidly advancing the growth of automation in the supply chain. Lydia Voice's deep neural network technology increases the value of automated mobile robotics, or AMRs, enabling greater results. EPG Lydia Voice's solution has proven track record as the most cost-effective, agile, and easy to integrate voice solution, making Lydia Voice the only logical choice when organizations seek to enhance many automation-driven processes. Visit us at epg.com. So now I want to turn it back to Dwight Klappich. Dwight, take it away.
Thank you, Bob. I'd like to build on what Bart was just talking about. We're going to focus the rest of the session on robotics. But before we jump into this, I'd like you to think about a few things. So I started my career with IBM back in the late 1970s. And at the time, the biggest computer IBM made was measured in K of memory, would take up half a building, cost millions of dollars. And there's a great quote from Ken Olsen, who is the founder and CEO of Digital Equipment, one of the first mini computer vendors. He said at the time, he said, there's no reason that an individual would ever have to have a computer in their house. Well, I don't know about you, but I have a supercomputer in my pocket, and we probably have at least a half dozen computers in our house today. And I think where we are in robotics is we're only at the beginning. We believe that within the next 20 years, virtually every business will have a robot doing something within their business, where today very few do. So the question is not going to be if people are going to do robotics. It's going to be when, where, and how much. And okay. So it's not going to be a question if they're going to do it, it's going to be when. And then it's going to be where, what, and how many. So is this hyperbole, that every business is going to have this? I don't believe it is, but getting ready for this presentation, did some research. Now, it's not surprising that the industrial robotics space, it's a very mature space. GM put the first industrial robot in to their factory in 1964. But that market's been fairly limited to fairly sophisticated companies that can build up the organizations to support that. So it's really been strong in automotive and in industrial electronics. But medical, think about it. You go into a hospital today, most hospitals have robots doing surgery, but many of you might not know there's other things that robots are doing. For example, we have one client that has a 5-hospital campus. They have a subterranean distribution network, and they're using autonomous mobile robots to move goods between their hospitals. So they'll pick up a train of linens, pull it from the laundry, take it to a hospital, all being done underground. So if that's where we are in medical, I think it's only logical that we're going to continue to see growth in other areas. So as mentioned early on, I've led a study with Gartner for 14 years where we survey supply chain business users about their technology strategies, investment plans, what their barriers and challenges are. And one of the questions that we ask in this study is, what are your plans for investments in cyber physical automation? And this number was astonishing to us. I mean, 96% of respondents to that study said that they plan to invest more in cyber physical automation over the next 3 years. That's where my 100% number comes from. This is a statistically valid study. I often emphasize that. It's across industry, it's across size of organization, and across geography. So that's a pretty notable, percentage. So what's driving that? We'll talk a bit more about the demand side, which is labor constraints are driving that, but where's the market at? The good news is there's lots of innovation continuing to take place, and things are progressing quite rapidly. We see new markets, expanding outside of, again, like I said, automotive's pretty mature user of robotics, but now retail, 3PLs, other distribution companies, other manufacturing companies are all now looking at robotics. We see new use cases cropping up every day. For example, if you'd asked us 3 years ago, we thought that picking robots were probably a 10-year technology, but we've accomplished in 3 years what we thought would be 10 years, and we're seeing, the ability of robots to accurately pick items improving day by day. The challenge for the customers is that the good news is there are lots of options. The bad news, there's lots of options. So, we spend a lot of our time helping clients sort through what are the options, where should they be focusing, what are the best opportunities in the near term for them. And part of their challenge is that they don't have the internal expertise. Now, the good news is if you ask someone if they want to play with robots, a lot of people raise their hands. So it's not that people are shying away, but they lack the expertise to understand what would I do, how would I do it, how do these things work, and they're trying to build that up very quickly, and that's leading to this confusion about what are the risks, what are the rewards, what are the best use cases, and people are starting to sort through that. So if we look at it today, we look and we say one of the fastest growing areas we call basic transport robots, move stuff around, move stuff from A to B. That is a very low value human task. And we believe that within at least the next decade, probably sooner, 3/4 or more of that is all going to be done in the future by autonomous mobile robots. It doesn't take advantage of the unique capabilities and skills of humans. It's a very boring job, and it's something that's automated already, and it's only going to get better over time. So I mentioned before that labor constraints was a key demand driver. This is another study that I ran. This one ran in the late 2019, so this is pre-pandemic. And this question, we asked it in a very specific way. We wanted a binary response. They either had to pick labor costs as a primary reason for investing in automation or labor availability. It wasn't one of those 3.5 down the middle. And so even in late 2019, you could see it was almost 50-50. Now, if I were to go back 10 years and ask someone why they're investing in automation, 95% of it would have been to reduce labor costs. That's why, where have we seen the most automation? It's where labor costs have been the highest, but this is statistically equal, 50-50. And I think if we did this same study today, that number would probably be even higher for labor availability. They just can't get enough people, so they need ways to automate it. And so it's driving it. Bob?
This presentation is sponsored by Fortna. Disruption has revealed supply chain vulnerabilities. The need for innovative automated technologies is critical to address labor challenges and the rapid growth of e-commerce. Emerging technologies can be harnessed for agility and scalability while driving competitive advantage. Fortna helps companies transform distribution by leveraging intelligent technologies and software to increase flexibility and capacity. Leverage the Fortna agnostic approach to evaluating technology that prepares your business for dynamic market and consumer demands. Learn more at Fortna.com. Vecna Robotics is the autonomous mobile robot company that helps distribution, warehousing, and manufacturing organizations streamline their materials handling and logistics operations. These self-driving fork trucks, pallet trucks, and tuggers are equipped with the most advanced navigation systems in the industry. They adjust to environmental changes and reroute in real time without human intervention. Customers have reported operational efficiency improvement by 30% and increased throughput by 50% using these solutions. Go to vecnarobotics.com to learn more. And so back to Dwight Clappage. Dwight?
So automation's not new. I've been doing warehousing for 40 years, and we were putting in automated warehouses in the 1980s. So the question is what is? So if we go back in time, we've had this challenge of finding the balance between things that make humans very good and things that make automation very good on the material handling side, and what we would refer to as conventional or legacy automation, conveyor sortation, shuttle systems, ASRS systems. They have certain advantages, so they're not going away. These are very reliable systems. They last 20, 25 years. They're highly integrated systems, so everything's built and designed and delivered to work together. They can move goods faster than I would typically move them in other ways. I'm not, or I shouldn't have somebody driving a lift truck 40 miles an hour, some do. But I can move a box on conveyor, a tote on conveyor that fast. and I can get extreme density of storage. The downside of legacy automation is that these are very expensive systems, 8 figures and up. These take a long time, 18 to 24 months from the time I start to the time I turn it on. And then not uncommon to see 5 to 7 year paybacks. And then I better get my design right, because changes after the fact are very costly, time consuming if I can do them at all. Sometimes I've built the building around the automation and I really can't change the automation, but if I can, it's still expensive. On the other hand, you have humans that are agile, adaptive, scalable, and intuitive. All the things that make a human being a human. I could take someone from the receiving dock in the morning, put them in packing in the afternoon. I can retrain somebody to do a new task. I can add people. I can, remove people. Humans can see a problem and try to find a solution using intuition, where everything in conventional automation has to be programmed in. And if I have to do something different, I have to go through a fairly complicated process to program it. So that leads to where we are now with the advancements in mobile robots. We've had industrial robots, as I said, for 40 years, but they were stationary and they were programmed to do one thing, and they did that 24/7 and did it very, very well. But in logistics and other environments, that's not what we needed. We needed something that was mobile, could operate in 2-dimensional space at a minimum, increasingly operate in 3-dimensional space, both travel on the floor as well as go vertical. There had to be intelligence. We've had AGVs, for example, for 50 years, but they used to be on a rail, then there was a wire, then there were tags and floors, magnets and floors, but they had a fixed path. And they were dumb as bricks. Now these robots have embedded intelligence. They can self-navigate. They can, find alternative paths if there's an obstruction. They're scalable. I can add one and I can grow it, where conventional automation, I got to design it for my 10-year growth, and I might be running it underutilized for 10 years. Before I get here. Here I can start with 1 or 2 and add them as I need them. They're sensory aware, so they can operate in and around, humans. Again, conventional AGV, for example, which is the closest thing to a mobile robot. You do not want to walk in front of one of these things. They're, like I said, dumb as bricks. Where you look at these robots, they have embedded sensors. They either have, LiDAR systems or visions guidance systems. They have instantaneous braking. Again, they can navigate around obstacles, so, collision avoidance capabilities. And some of these are highly adaptive. For example, there's a company that does floor scrubbing robots, Brain. And I was at a trade show. They said, "Hey, you want to, kind of play with the robot?" And they said, "Well, why don't you trade it?" And so I got on the robot and I put it in training mode, and I drove this, crazy path like a drunken ant, and took it out, and they had it run. And sure enough, literally, I didn't know a thing about it. I put it in training mode, and sure enough, it was, adapted to a new process, kind of crazy process. But it works. So all of this is what's, helping drive, this marketplace. So when we talk about robots, people don't buy robots. That's people, investors invest in the robot industry. But it's like talking about the automotive industry. People buy SUVs and pickup trucks and things like that. And it's the same thing here. We talk about this in aggregate, but there's different kind of broad styles of robots. And we're going to talk about a few here today. There's collaborative picking, or what we call in-aisle picking robots, 6 Rivers. This is a picture of, Locust. These are robots that are designed to work with humans. I might be working in aisle A and Sally's working in aisle B. Robot comes to me. There's 4 orders that I'm picking to on the robot. I go down my aisle. When I'm done, the robot goes to Sally. Sally picks hers. But it's really designed that collaborative, the human and the robots working together, and the coordination of the human and the robot activities. Then there's what we just call basic transport robots. And we don't mean basic in any negative way. It's that they're just many activities that I just need to move stuff around. An example in the upper right-hand corner, is Vecna, who, Bob mentioned a moment ago. This would be what we call a heavy payload vehicle. Bottom left is another example of a heavy payload vehicle. You can tell what makes a heavy payload vehicle. It's going to be the size of the motor, transmission, the chassis, the frame. It's designed to move heavy weight. The use case example in the upper right is what we call a tugging use case. That's a train. That hospital I was talking about, the robots underground might pull a train of 5 racks with linens on it. The robot autonomously connects and it drives the train. The bottom left is, more of a conventional kind of lift truck use case where it's, got forks and it's picking up a pallet and can move it around. We now have the ability to go up about 6 feet. I said, 3 dimensions. We're not quite to having fully autonomous lift trucks where I can go 30 feet up in the air, but we're getting close. Then we have other use cases. The upper left, vendor Fetch. We're seeing a lot of interest in replacing power conveyor with robots. Why have to bolt, conveyor to the floor? I could have a robot dock at one end, take an item, in this case, a tote, take that tote across, my facility dock and another set of rollers, and it goes off. That way. Bottom's the company Mir, similar kind of thing that's just bigger. I think that's a kind of a 1,500 kilo platform, if I'm not mistaken. Then we have goods to person systems. Many of you might have heard of Kiva in the past. It was acquired by Amazon in 2012. They're now new vendors. This is an example of a company called Gray Orange. There's Geek Plus. The thing here is the robots deliver goods to a person that stays in one place. It brings these shelving units, and I'm picking from one set of shelving units to another set. So I could be picking, 1 order, 6 orders, 9 orders at once. The robots just keep delivering shelves to me as I pick my items into my orders. When I'm done picking all the orders, another robot comes and takes it away, takes it to the packing area. This was something that became quite interesting to companies in the age of COVID. This is a very effective way to social distance. Keep the person in one place, let the robots do the movement. And then there's even some similar but kind of different use cases, like an NVIDIA Robotics that delivers, a case or a product one at a time to people, as opposed to moving a full shelving unit. And then on the bottom right is we have robotic picking systems, where it's a combination of robotic arm, some form of gripper technology, and then a camera and very sophisticated AI pattern recognition software. Vendors like a Right Hand, and IM Robotics, a Kindred, a Berkshire Gray, and others, very sophisticated. Now the robots can look into a tote and identify items in various orientation, size, weight, shapes. Is it standing up? Is it on its side? It can effectively pick those, where in the past, I had pick and place kinds of thing. It had to give it to me in a certain position so I could put it in a certain position. Now I can deal with much more volatility. And then the far right, we start to see these being put together as integrated or engineered systems, where you see companies like an AutoStore, an Exotech, and Adabotics, where they're taking advantage of some of the strengths of the robots and gaining some of the strengths of conventional material handling, such as density of storage and some of those types of things. So the good news is, I said, there's lots of options. The challenge is there's lots of options. Now, the value proposition is very strong, and this is why we think, growth is just going to be exponential. One is I can start small. Conventional automation, 8 figures and up. I had a client recently, all they'd say is they're spending over $100 million for their highly automated facility, and they could justify it. But here, in some cases, I can pick up a robot, and start, and then do some experimentation for a couple grand a month. And some of that's going to just depend on the size of the vehicle and some other things. But regardless, I'm not talking 8 figures to get going. A significantly faster time to value. I can be doing productive work in a month or 2, or again, it might be a 1.5 years, 2 years before I move my first box in conventional automation. I can focus this, again, in conventional, I'm designing because they're so integrated systems. I'm really targeting everything at once. Here, I can just say, look, I've got this basic use case. I'm going to start there. For example, one client said, hey, we're just going to start by doing dunnage. We're going to move trash. We're going to set up a situation where, we put broken pallets and corrugated at the end of the aisle, and a robot just comes, picks it up several times a day and takes it to the compactor. Very simple use case. They did that because they say, hey, that's an easy one for us to work on, then we'll get to learn what the robots do. And then you can kind of move that through, pilot and design and retest and find new use cases. And that's going to let you, as you start to then get better and better, scale up your use of the robots. So what we saw in that same study, we asked what kind of people you need in the supply chain organization. This is going to be one of the challenges for many companies is 58% of the companies said they were going to need more, automation, material handling engineers, and 44% said robotics engineers. The good news, if you have a child in college, tell them to go into engineering because they have a guaranteed job. The challenge is there's already a shortage of these people, so there's going to be a lot of competition. But this is what people are going to have to either build organically or develop from the outside. So in closing here, I think, where people need to head. If you look at most companies today, very few have gotten beyond a single robot platform. And by robot platform, I say, hey, I've selected this platform to do in-aisle picking for me, and I'm using 6 rivers. We believe, just like they have heterogeneous fleets of other material handling, they're going to have heterogeneous fleets of robots. So we believe organizations are going to move towards having a robust, center of excellence that's going to take on multiple roles within the organizations. It's knowledge gathering, educating both themselves and the rest of their organization, socializing robots across their organization. And then as the fleets start to grow, things like governance and control become a much bigger issue, and the COE will take on a lot of that. And with that, I'm going to end here and open it up to see if anybody has any questions.
Thanks a lot, Dwight. So yeah, we do have a number of audience questions, and even as we are answering them now, audience members still have time to submit additional questions by clicking on that button at the top of your screen, bottom of your screen that says Q&A. So let me see where to start here. There's a lot of good ones. This questioner is asking for an example of diagnostics analytics and how different they are from descriptive ones. Maybe they're talking about the transition from descriptive to predictive to prescriptive, maybe. Which of you gentlemen would like to help out with that insight?
Yeah, I'll do that, Bob. Thank you for that question. And maybe I can relate it to a simple example of your car. If you're driving your car, I can describe what the problem is. I don't know what the problem is. So when you go to your dealership and you say, hey, my car makes this weird noise, they run the diagnostics and they can basically see there's a fault code on your engine or whatever that causes the problem. That's what the problem is. So if you look at it as an example in the supply chain, we could say something's going wrong in transportation or in manufacturing. We can say as a descriptive analytics that on every 10,000 machines we make, we have 5 faults or 5 machines that are not working perfectly. But then the diagnostic, what it does, it has the correlation to correlate data to then say, this is why these 5, where it went wrong and what's the causes of the issue. So it creates additional intelligence around that historical analysis.
Okay, thank you. This questioner's asked, what proportion of automation are you seeing throughout the various stages of pick and pack fulfillment, picking, putting, packing, etc.? Are there any companies you care to highlight who specialize in automating specific stages?
I mean, we could spend the next couple of hours. I mean, I think, as I said before, there's lots of options. Picking was one that we thought was going to be a 10-year technology. If you talked to us 2-3 years ago, we didn't think the pattern recognition was going to be good enough, but that's a technology that's progressing much more rapidly than we thought. And it's very interesting. It's the transfer learning. one of the things I didn't mention about robots that's very appealing. You train one, you train them all. So if you train one robot to do something, then all the robots now are there. Where humans, that is one of the challenges. You're always starting from zero and retraining them. So the robots are getting very good. So some of it comes down to use case. I mean, from a picking standpoint, I think, items that are, a little lighter weight, or cellophane wrapped or bottles or things like that, those are good. Picking big, clunky items like a 30-pound kettlebell, theoretically we could do it. It's less an issue of could the technology handle it, but the gripper and the gripper technology. So we don't have that one universal, technology at this point in time. But I mean, the fact is we're seeing now robot to robot to robot, where people are building a system where one robot's delivering a tote to a robot that picks it out of the tote. That robot actually puts it on a sortation robot like a Tompkins T-sort that delivers it to, maybe a packing station. Might still be a human, but there's no reason down the road that human can't be replaced by a robot. So it's not any one, I think, we're applying them in all of them.
Okay, thanks. Thank you. Could you elaborate on the safety technology and processes and how safety organizations are keeping up with the robotic functionality concepts? What advancements do you expect in safety standards in the next 5 years?
Well, I have to be honest. I mean, we have other people in Gartner that get into some of that specific thing. So yes, I mean, there's a lot going on and standards trying to be written around that. But I think in general, people are finding that the robots are actually safer in many cases than their human assets. A significant percentage of accidents caused in warehouses are caused by humans, driving too fast, not following the rules. So the key is if you have a robot and there's a stop zone, it stops. It's not an option, it stops. Where, humans, they do rolling stops and they blow through. So short of the actual standards, which I don't get into, I look at how people solve the business problems with these, we're actually finding them to actually be safer in many cases than the humans.
Yeah, and I can add my perspective as well. If you look more at the road vehicles or even off-road, right? Where, for example, autonomous trucks over the road are fairly new, but we've been using that for over 12 years in mining, where we've seen the amount of incidents go down pretty much to zero. When we look at it over the road transportation, if you look 2 years ago, we introduced the ELD that was supposed to make driving safer. And what we actually saw, there was more incidents in over the road trucking transportation because the drivers would get more stressed out because the effects of ELD and reducing the drive time. Last year, there was a lot less traffic on the road, but yet we saw the number of incidents increasing. Why? Because people were more distracted. So there again, we're using some of that technology with autonomous vehicles and not just, I mean, the different levels of autonomy, even level 3 and 4, where you have assistance in the human driving, is increasing the safety. When you have lane assist, for example, or we're starting to use cameras in the vehicles, not just the regular mirrors, but you're putting video cameras on the side of a truck in the back where you're completely seeing dead corners. All of that is leading to safer drivers. And now we're starting to also start predicting based on data where you can, instead of what we can see with the eye, where vehicles can see 1,000 feet ahead of them, can stop a lot quicker. So all in all, we see transportation safety being definitely one of the key items in bringing these vehicles to market as well.
Great, thank you. Will you elaborate more on competencies needed for robotics, including intelligent automation? I think here we're addressing the issue, the changing role of the human in the robotics environment.
A great question, and I'll plagiarize one of the founders of a robot company. She had a great line. She said that when they go into a customer and they see a robotics engineer, they get worried because robotics engineers are educated to design robots. She goes, that's not what they need. When they go into a customer, what they need are people that know how to solve problems with robots, and that's different. I don't need someone to worry about the feeds and speeds of the motors at that point. I need to say, well, what's the problem and how would I solve that problem? And so we're seeing people start to adapt. The challenge is that this, if I were to say the robot, the perfect person has a combination skill set. They have business acumen, they have engineering capabilities, and they have IT capabilities. Now, you'd love to say it's 33% of each. That people are going to be hard pressed to find many people like that. But you need the business because they need to understand, well, what's the business problem I'm trying to solve and what's it look like? You need the engineering. This does bleed into, understanding how to solve problems with engineering kinds of things. And then there's a certain amount of IT. We believe that over time, there is potentially new organization. We actually believe this will occur, that there is going to be a robotics organization that looks an awful lot like IT. Now, there's going to be competition. IT might want to own this. Engineering might want to own this. We think it could be a separate organization with a chief robotics officer that brings that skill set into the center of excellence. And we have actually seen that in certain organizations. Certainly Amazon as being one of the most famous, has a very large organization focused on robotics. Automotive companies have that. And we have one example of a 3PL that's building that up, where they're bringing that kind of combination skill set together, because you need all of that.
And maybe just to add on to that, Bob, I mean, we see it across the supply chain, right? Where we're seeing, if you look at 2030, 2050, even 2100, the workforce of the future is drastically going to change. And we're seeing that as companies are continuing to digitalize, that we need much more of a digital workforce in the future. So that's something we're seeing across the supply chain.
The emergence of the CRO. You heard it here first, folks. We'll see what happens.
You can come to my presentation at the Gartner conference.
There you go. What is the proportion of brownfield versus greenfield do you see in these digital transformation engagements? To what extent do you need to start from scratch in order to implement this technology, or adapt it to existing facilities, I guess, is the question.
I seem to be answering all the questions. I apologize to Bart for that. But I mean, from a warehousing standpoint, that is one of the allures of the operational robots, that I don't necessarily need to do a complete greenfield. Now, I could put conventional automation here, brownfield, go into a building, rip everything out and put automation in. Sometimes that was suboptimal because I had to deal with the constraints of my building. Where take 6 Rivers, for example, I have all my racking, everything's already in place. I can introduce that robot tomorrow and not have to make any changes in my infrastructure. Now, and then there's, I don't necessarily get all the benefits I would get, say, of, being able to go 40 feet up in the air, so you might have to rethink. So maybe now I need to add a mezzanine so I can take advantage of roof height, so I have, 6 Rivers on one level and 6 Rivers on another level, but I can't, unless you have very, very tall people, they're kind of limited to about 6 feet, in conventional automation. But that's the beauty of it. It's very low cost to actually introduce. Same thing with the transport robots. I don't have to, put down wire or conveyors or, stuff like that. I can just introduce it and it can move around in my existing environment.
Right. Thank you. Is there a difference in the adoption of automation technologies between SMEs, as small and medium-sized enterprises, and large companies?
Well, we see that definitely, if you look at it from a transportation perspective, where we're seeing a lot more adoption with the larger companies. And why is that? Because we typically see the larger organizations typically have more supply chain maturity. So they're the ones that are the most risk averse and investing typically first in a lot of these technologies. So we've seen the large guys out there. It's the AB InBev type of companies, the Electroluxes, et cetera, that were the first out there trying out, autonomous trucks. Same on the 3PL side. We're seeing a lot of the advancement being done by UPS and FedEx, and the retail side, Amazon and Walmart. So we typically see it starting with the larger guys, and then we typically see smaller companies once they've tried it out, they've proven it, and also the cost of these products come down, at least for transportation, then we see SMEs taking over some of those products as well.
Okay.
Yeah, if I could just add, I think from the robot side, I would agree. It is still bigger companies, but they have the organization. But I think the small medium enterprise business is ripe because again, they don't have the capital to spend $100 million on a highly automated facility, but they can get some benefits fairly quickly. So hey, I could just go out and get 5 robots and get maybe not 100% of the benefit, but 60% of the benefit with very low risk, very low upfront capital. The fact that many of the robot companies do this as a service, robot as a service, that keeps down the capital. I think what's holding those companies back was what I said earlier, they don't have the internal expertise. And to be frank, some of the boutique consulting companies that would have helped people with this, kind of come from the conventional automation, and they're starting to rapidly build up, practices so they can go out and help customers with this. Because some of those small companies, like I said, we already have labor constraints, and those engineers. So that's an opportunity for a consultant to provide that kind of expertise for them. So.
Great. Okay. This is a question about the autonomous supply chain, which is a term that's been kicking around a lot lately. This questioner is asking how different it is or related to the automation development presented in this presentation. Maybe you guys can tell us a little bit about how this relates to the so-called autonomous supply chain.
Yeah, maybe I'll start first here. If you look at, and I think Dwight alluded to it with automation, right? A lot of times automation has been more, what have we programmed? So autonomous is quite different, right? Where we have more, machines that can operate independently and learn on themselves. Now, if you look at that across the supply chain, when we look at an autonomous supply chain, it's not just the technology, right? Where we need to have the processes in place, we need to also have the organization in place to be able to drive that autonomous supply chain. And what we've seen in Gartner studies is that most organizations aren't ready for that. Most organizations are still, want to have the control over how they drive certain functions, and especially kind of end-to-end supply chain. So that I would say is quite a different, where we see automation much more on specific tasks and events, where autonomous supply chain really needs an entire organization across supply chain with the people to follow kind of more of a business and process automation, which, as I alluded to as well in kind of the 3 phases, is still a ways to go for supply chain organizations.
Okay. Right. Let me see. This questioner is asking for insight related to the solar wind case and adaptation of technological innovation in the supply chain regarding autonomous and robotics systems. I guess, is this a cybersecurity question? You guys want to address this, or where does that come into the picture?
I have to be honest, I'm not sure I understand the question.
Well, I thought it might have something to do with cybersecurity. And then that is a concern, I guess, that people might have with the application of robotics to a sensitive and proprietary operation, whether the automation is secure. So maybe that's something you could address.
Well, in that same study I keep referring back to is we ask a question of what are some of your top concerns, and cybersecurity was at the top of the list. And that has been moving up and up. And this was before some of the recent events. And this comes back to why I said, you need engineering and IT. There's OT and OT security issues and IT security issues. And those 2 organizations, what we talk about IT-OT convergence. So it's not just the robotics. I would say some of the robotic systems might be safer than my 30-year-old PLCs that I have controlling my conveyor today. The reality is there's lots of vulnerability already in supply chains, and it's becoming a bigger issue. Now, where people are headed with that, I think there is that all owned by IT? I think in some industries, they're further along. Some of our colleagues that focus on the OT side certain industries like petrochemicals industries and, mining and some others that have been living with, OT for longer are further along in this, where I think in the logistics space, this is new, but it very quickly became a big concern. So I think organizations are really working on that. And again, we think that there's going to have to be somebody in the supply chain organization that kind of stakes on this as a core role, not independently, but, in collaboration with, IT and other organizations.
Thank you.
Yeah, and we're seeing as a lot more of these newer systems go into the cloud, where in the cloud they're using these cloud bots, and some of these are being developed to wear off these cybersecurity attacks, right? So we're getting on these cloud platforms smarter as well. Although we still see, like SolarWinds, we still see those things happening. That's why, as Dwight said, it doesn't matter what industry it is, even in the transportation industry, cybersecurity is top of mind for CIOs. So we're still vulnerable there. But as I said, as we're moving more and more of these applications into the cloud, they're developing very rapidly a lot of security, and by using AI and machine learning capabilities to wear off some of these attacks and recognize these attacks, just like we in supply chain are predicting kind of disruptions. They're doing that from a security disruption perspective.
Great. Just time for a couple more questions. This questioner says, Dwight says that we are moving toward a world of heterogeneous fleets. And in the abstract, I agree. The questioner agrees. But isn't it hard right now to coordinate operations, scheduling, material movement, et cetera, across platforms? Good question.
The answer is that is going to become a bigger issue for companies today. If I have a single, platform, I'm 6 Rivers and I'm running Manhattan WMS, I can have a point-to-point integration. We believe, again, most companies will have heterogeneous fleets, and we see the emergence of kind of, I hate to use the term middleware layer that takes on 2 responsibilities. One, integration, allowing me to integrate to those multiple pieces of automation, and then orchestrating work. So for that example, where remember I had Fetch, doing that replacement of power conveyor, it's not just talking to the robot, it says, but when the robot docks, it knows it docks, and the tote can come onto the robot, and this thing when it gets to the other end. So it's even coordinating and integrating to other pieces of automation. So absolutely, that's becoming, and it's that 3PL I mentioned several times. We had a conversation yesterday. They have something like 1,000 projects going on and across. Guess what? This is top of mind for them. This was our whole conversation yesterday. Where, to be frank, not many companies have gotten there yet, but they will.
Okay. We are just about out of time. Only time for one last question and one quick answer to it. And I know it requires a lot more than that, but let's see if we can do this. With so many options, where should companies start their automation journey?
Well, I'll make this simple. Go back to freshman year science class and start thinking about the scientific method. And if you can think about an iterative approach to looking at this, that's a great way to start. Identify a few use cases, formulate some hypotheses about those. Hey, I think there's a real opportunity for us to reduce the wasted time in moving dunnage around my warehouse, for example. Yeah. Well, then you can actually say, okay, how would I test that hypothesis out, run some experiments on that, see what the results of the experiments are, see if you could refine those experiments, kind of rinse and repeat and go through. And we started to see organizations develop this, again, through the COE, and being able to start look at those things. That's why I said they'll go through that, socialize some of that with other organizations, refine the use cases, and just kind of continue. And that's what's the beauty of this is it's incremental. And I don't have to do and think about every eventuality up front. I can kind of start small, build. And what'll also come out of that is you might say, well, hey, I've got this new use case. Maybe I need to go look at a different type of robot. Hey, I've got this use case now, needs to move 10,000 pounds, but I'm 6 Rivers. So I'm going to go talk to Vecna.
Okay.
you know,
Cool.
for that use case.
All right, we have to cut it off now. Unfortunately, I'm very sorry about that. I wanted to thank Bart DeMonk and Dwight Klappich so much for a fantastic presentation. And folks, you can hear more from Bart and Dwight and the rest of the Gartner team on this and a host of other supply chain topics at the Gartner Virtual Supply Chain Symposium and Expo from October 25th through the 27th. You can register with that special discount code you see in the lower left-hand corner of your screen. Once again, thank you, Bart. Thank you, Dwight. Thank you, audience, for listening in and for your fantastic questions. Everybody, have a great day.